Hey everybody, this is Mr. Johnson, and we're going to go through the last 3 questions on your proofs packet. And then after we are done with the video, hopefully you guys are going to be getting the chapter study guide, and you guys can work on that individually today, and then tomorrow you might be able to collaborate a little bit, hopefully have the key and maybe a few videos to go along with that as well. But let's finish up the packet so that we're all good on the proofs and how to go through the flow of a proof and kind of what we should say for statements. How do we start? Where do we go? So we're starting off with question 19. The diagram that you have looks something like this. A is on top, B is over here on the left, C, that makes a big triangle ABC, and then D, E, kind of in the middle of that line segment BC. Now for this problem, we are given a couple of things. Specifically, that AB, that line segment, is congruent to AC. So if I go to my diagram, AB, so if I go ahead and go to my diagram and I mark this, AB is that line segment, AC over here is this line segment. Okay, that was given. Next thing that we're given is that BD, that line segment, is congruent to CE. Sorry, my congruent symbols are trash. So BD down here, this little short stub, and then CE, that short stub. Notice we went from the corner inwards, that way they correspond. They're kind of the same reference. So those are the same length. If we put them on top of each other, they would match up. And so all of these things are given. So we can draw our line here and just explain that we know that information from the problem. Now after that, it is our goal to prove that triangle ABD is congruent to triangle ACE. It's always important to know where we are going. So in terms of that idea, ABD is this triangle, and we want it to be congruent to ACE, that triangle. Now it looks like this yellow triangle over here on the left is congruent to the triangle over here on the right, but that's what we're trying to prove, and we're going to have to go step by step to get there. So the first thing I think we can maybe talk about are some angles. Anytime you have two sides that are exactly the same length and they're meeting up here at the top, I think we have kind of a isosceles triangle going on. So if it's isosceles and I go all the way over in the opposite corner from that side, this angle should be the same as going to the opposite side of the other congruent side. So across here goes there, across there goes there. So that means B and C, those angles should be the same. So angle B is congruent to angle C. Now the reason behind that is it's kind of like the isosceles triangle theorem, but it's backwards. And anytime you're going backwards, that is called the converse. So it is the converse of the isosceles triangle theorem. After that, I'm looking, we have an angle, we have a side down here, we had a side that was kind of over here. If we have a couple of sides and an angle, and if they're ordered in the correct way, we might be able to say something about triangles. So I'm looking here, side, angle, side, side, angle, side. Well, that means the triangle here on the left and the triangle here on the right, those are congruent. So triangle ABD is congruent to triangle ACE. And that is by side, angle, side, SAS. And actually, if we look at our goal, was to prove that those two were congruent, and I've done that with just 3 simple steps. So not that bad to get all the way through question 19. Understanding that the converse of the isosceles triangle theorem, that was kind of the key pivot point to solving that problem. If we go ahead and look at question number 20, this one's going to take a little bit longer. It is exactly the same shape though. So looking at what they've given us the triangle ABC is equilateral. So it probably would help if we had letters on here. That's my bad. A, B, C, and then D, E is still on the inside here. So if ABC is equilateral, I'm going to underline this in kind of orange red. That means this guy, and then this guy, all the outside edges should be the same length. If you want me to color coordinate here, I can do that. So we'll go red with red with red. Same lengths. Now, diagram probably not drawn to scale, but we'll live with it. After that, I'm also given that BD, that line segment, is congruent to CE. Okay, all of these things are given. Those are like the ingredients to your recipe. They're like the instructions, the materials that you need to build this whole thing. So BD, over here, this short low guy, CE, that short low guy over there, they're the same. So actually I have a very similar setup to my last problem. You're going to notice that quite a bit. So the next thing that I need to do is figure out where my goal is. Where am I trying to go? So I want ADE to be isosceles. Okay, again, that's my goal. I'm trying to prove that. Alright? So ADE, if I'm going to do my goal, ADE is right here. I would like that to be isosceles, which would mean that and that have to be the same length. That's my whole goal. I can't say that yet, okay? But we're going to get there, and we're going to prove that that inside triangle is isosceles. It certainly looks like it is. So the next logical step that I'm going to have to take in this is talking about those angles again. If I have an equilateral triangle, equilaterals do similar things to isosceles a lot of times. So over here in the corner, angle B, it's across from that side. Over here in this corner as well, angle C is across from a side that's the same exact length. So I know that angle B has to be congruent to angle C because it's the converse of the isosceles triangle theorem. Just use that in problem number 19. After that, if we look at those two triangles, we have side angles and sides. They are going to match up and be exactly congruent. So it's not the inside triangle yet, but it's these two outside triangles, and that's kind of narrowing in on the goal. So those are yellow. So triangle A, B, D, top, outside, inside, needs to be congruent to ACE. Again, same order, top, outside, inside. And that is from side, angle, side, which is the exact same reason we used in the last proof. After I know that the left-hand triangle and the right-hand triangle are congruent, I know something about those inside sides. Anytime we have congruent triangles, all of their pieces must be congruent. They line up perfectly. That every piece, every little bit of them will do that. So I know that AD, that line segment, must be congruent to AE. And that is because corresponding parts of congruent triangles are congruent. If you have triangles that are the same, every piece of them will be the same. That's the layman's term of CP/CTC. So now that we have these sides, these sides, these sides all measured out, all marked, and I look at the inside triangle, which I'll make green this time, right in there, that inside triangle has two sides that are the exact same length. So I know that triangle ADE is isosceles. And that comes from the definition of isosceles. So my end goal, got it. Question 21 is kind of a weird looking diagram. Okay, A is up over here, B is off on the right hand side, we got C and D down in the corners, and then in the middle you got G, E, and F. Now, a couple things that they have to give you. Triangle GEF, good old Jeff, they say that GEF is equilateral. Now, I know it doesn't look like that, but equilateral means every side is the same length. So if I'm going to go ahead and mark that idea, that guy, this guy, and this guy have to be the same length, so they all get the same tick mark. Another given, line segment DF congruent to line segment CE. So DF, we'll go back to green, DF goes all the way from here to there. Now that is congruent to CE, and I'm going to place them slightly off kilter so you can see green and green. They're the same thing. All right. They are congruent. Not the last given. They actually have one more. They say line segment AF is congruent to BE. Now this part is critical. I didn't see this when I was trying to prove it the first time, and I got stuck because this is a piece of crucial information that we can't work without. So all of these are given. So marking AF and BE, we'll do that in yellow. AF goes from up here, top left, down to there. BF goes from the top right down to there. Okay, if we really wanted to mark all of these, we definitely could do that. So I'm going to go ahead and mark this guy with 2 and 2, but the colors help out as well. 3 and 3. I can't assume that any of them are the same length. I don't know if the green and yellow are the same length. They might not be. So the next piece of the puzzle is to figure out where our goal is. My goal is to prove that AD, that line segment, is congruent to BC. So AD being over here, this guy, I want to show that that is the same thing as that guy on the right, which doesn't seem that hard, but I'm going to have to figure out some information here in the middle. So notice I have yellow and yellow, green and green. That's a really good start to getting that side and that side nailed down, but sides and sides need a little bit more. So you'll notice over here in the corner of yellow and green, kind of this first angle, I'll label it angle number 1, that actually should go with this angle over here. And we can say that because of the red tick marks here in the middle. Those red tick marks mean that it is equilateral. So angle 1 is congruent to angle 2. And actually, all of those would be congruent to that third angle up there, but that guy's not really important for the proof. So that is from the definition of equilateral triangles. They are also equiangular. Now I'm not sure if that's what your proofs packet would say, but the equilateral triangles go with equal angles. They're all 60 degrees. That is probably putting a couple of those theorems together. I don't know if the other math teachers would accept that or not, but I think I might for the moment. After we know that, I'm kind of looking around to see what we have. Looks like we have kind of a side. We have an angle in this overall triangle right here, that triangle, and then we have another side. So if I have a side, an angle, and then a side, that means something about the triangles. This bigger triangle on the left, overlapping with the bigger triangle here on the right, they are congruent. So triangle AFD, so top, inside piece, outside piece, that guy is going to be congruent to triangle BEC. I got to go in the same order, top, inside, outside. And that is from side, angle, side. Here's my side, here's my angle, here's my other side. So we're super close to proving that this is the same as this. If I know that I have congruent triangles, then I know all the pieces of the triangles must be congruent. So that means that AD, that line segment, must be congruent to BC. And that is because corresponding parts to congruent triangles are congruent. If the triangles are the same, all the pieces are the same. Looking back at my goal, that's what I wanted to prove, and these are the steps to get there. Hopefully this little video helps. As you look through your study guide, I would like you to kind of zone in on a couple of things. I took the time to look at the test, since I'm not really familiar with this chapter, having never taught it before, and I wanted to see where most of the points were coming from. So you guys are going to be taking a test on CO.5, CO.6, CO.7, and then CO.8. So those 4 different targets. CO.5 and CO.6, if you kind of look down here, it's 7 problems. So they're all kind of lumped together. Now it's 40% of your grade. So it's important, and when you're looking at your study guide, you might want to make sure that you really understand those 2 ideas. From what I saw, they weren't as hard as maybe some of the proof stuff here at the end. CO.7 only has 4 problems, and it's only worth 1/4 of your grade. Doesn't mean it's not important, but you should be thinking ahead of time that there is not going to be as much material on that. It might be because those problems are harder. I haven't tried them yet. CO.8 is 7 problems and 35% of your grade, so it's a lot of problems, and it's about the same percentage as what was up front. So as you're going through that, kind of try to put your time in the places where it is going to benefit you the most. On Monday of next week, we are going to be testing. So you guys should be prepared and ready to start the test on Monday. I'm going to have the key and some videos tomorrow, hopefully, so you'll hear from me again. Take care, guys. I'll see you soon.